Assalamualaikum warahmatullahi wabarakatuh. My name is KAMELIA binti ABDUL SHUKOR and I'm from class A4 CS1432A. And for the subject MAT183, which is calculus 1, me and my group mates will be presenting about application of differentiation. There are 4 people in my group, and the first is FAIZATUL, second is ERNI NADIRAH, third is SITI KHADIJAH, and the last is me, KAMELIA.
What is a related rates? Related rates is a problem involve finding a rate at which a quantity changes by relating that quantity to other quantities whose rates of change are known. The rate of change is usually with respect to time because science and engineering often relate quantities to each other. The methods of related rates have broad applications in these fields. Differentiation with respect to time or one of the other variables require application of the chain rule, since most problems involve several variables. The example of related rates. Real-world application of solving related rate problems are numerous. For instance, a gas company might be interested in knowing how quickly a tank is filling up, or an environmentalist might be worried about how quickly a particular marshland is flooding.
I would like to talk about why we use a related rates. As you guys can see on my slide, a related rate can help us to understand and predict how fast systems change over time. This method also is particularly useful in solving problem involving motion, such as determining the maximum and minimum value of a function to find the point at which two functions intersect. For example, a related rate can be used to find how fast the height of a water balloon is changing with respect to time when the radius of the balloon too is changing with time. This can be used to find the maximum height of the balloon. To summarize my point, a related rate is a powerful tool in calculus that allows us to understand and analyze the relationship between different variables and their rate to change, which can be useful in solving optimization problems and understanding a real-world phenomena.
Now, we will talk about the problem statement. The problem statement is a 20 feet long ladder raised against a house on a flat ground. The bottom is initially 8 feet long away from the house wall. The ladder is moving up when it is being pushed towards the wall at the rate of 1 per 5 feet per second. Calculate how fast the top of the ladder moving up the wall 5 seconds after we start pushing. The objective for this problem is to determine the rate of the top ladder moving up after pushing it and to apply the Pythagoras theorem into differentiation. As we can see, this is the illustrative image before the ladder has been pushed. We can see the 20 feet ladder is raised on the wall. At first, the bottom of the ladder is 8 feet away from the wall. After we push the ladder at the rate of 1 per 5 feet per second, the value of x, or we know as the bottom of the ladder from the wall, will decrease. To find the rate of the top ladder, or recall as y moving up after 5 seconds, we can draw and label the quantities given related to the problem statement. From the problem statement, we know that the bottom of the ladder is 8 feet away from the house wall. The ladder is also moving up at the rate of 1 per 5 feet per second. Based on the question, it passes how fast the top of the ladder is moving up, which is dy over dt. From the info given, we know that dx over dt is 1 per 5 feet per second. Then, we need to find dy over dz. From the figure that we have drawn, we know that this equation is related to Pythagoras theorem. As we all know that the Pythagoras theorem formula is a power of 2 plus b power of 2 is equal to c power of 2. Therefore, we can substitute the information has been given into the equation and then we need to differentiate the equation. We know that the bottom of the ladder is 8 feet away from the house wall before it being pushed. So we need to find the distance after it being pushed. We use the formula distance is equal to rate times time. We substitute the information given, and after we calculate, we will get to know how long the bottom of the ladder from the house wall after 5 seconds. Since we already know the value of x, which is 7 feet, we can find the value of y. We use Pythagoras theorem once again here in order to find the value of y. We substitute all of the known value into the formula, then we will get y is equal to square root 351. After that, we use the equation we get before, which is 2y times dy over dt plus 2x times dx over dt equal to 0. Substitute the value we got in order to find dy over dt. Then, we will get dy over dt is equal to 0.075 feet per second. So, the rate of the top ladder after being pushed is 0.075 feet per second.
Assalamualaikum, I'm KAMELIA and I will be talking about the second part of the problem statement. A conical water tank has a radius of 5 cm at the top and 12 cm high as shown below. Water flows into the tank at the rate of 10 cm cubic per second. Applying differentiation in this situation, we can calculate how fast is the height changing at an instant when the height of water is 6 cm. So from the question, we can conclude that what we are trying to search for is dH dt. In order to solve it, we have to start from the formula of a cone, and that is V equals to 1/3 pi r square h. But to solve it, we would have to eliminate variable r from the formula, and that is what's happening in the first part of the calculation. When putting h over r equals to 12/5, we can put r as a subject in terms of h. And with this, you can substitute the new value of r into the formula. The next step is to search for dv over dh. Using the new formula, you can differentiate v with respect to h. As I've mentioned before, what we are trying to search for is dv over dt. And now, we can calculate it by multiplying dh over dv with dv over dt. After subbing in the values, you will get 0.5093 cm per second, which is the answer for the problem statement.
Well, I think that is all we have for today. Now let me summarize what we talked about. So by using the differentiation method to this situation, we can determine that differentiation could be applied to define a value of a volume, solve the problem related to the how fast the object moving and the height changing. So I will end the presentation, and I'm very honored to say thank you for your time. Thank you.
I hope you can get helpful knowledge from this presentation. Thank you.